everyone. This is an example of a custom signal challenge 1. Okay, and this signal consists of unit step and ramp functions. So go to the questions. The startup procedure for a batch reactor includes a heating step where the reactor's temperature is gradually heated to the nominal operating temperature of 75 degrees C. The desired temperature profile Tt is shown in this figure below, and then we need to determine Ts. Okay, so given here is a graph that's showing the temperature profile of T at T domain. Okay, so before we can proceed with this custom signal, okay, let's check the table of Laplace transform. Okay, so in the table, what we have is Ft, that's showing us what is the Laplace transform, right? Okay, so the table of Laplace transform for unit step St, unit step functions, when we have Laplace transform, okay, it become 1 over s. And if we have ramp functions, okay, when we apply Laplace transform, what we get is 1 s power of 2. Then we have condition of functions from t to minus t naught s t minus t naught. When we apply Laplace transform, what we get is exponential power of negative t naught s, okay, and the function is in s domain. Okay, so this one is from the table. Okay, now let's look at the plot here. Okay, the plot here for the x-axis, okay, which is time here, starting from 0 to 30. Then for the y-axis is temperature profile here, is starting from 20 to 75. So if I have this plot, okay, I plot starting from 0, okay, for 0 to 30 for this t-axis, this is time, okay, and 0 for this y-axis, and then 20 is here, 75 is here. Okay, what I can have is the plot is starting from this point, okay, go up until 30, and then we'll go constantly to 75. So from this 0, I actually have a line here to show that this one is a unit step input. Okay, so if I can write this, what we call as a piecewise defined functions, we define as piecewise defined functions. What we can get here is Tt, okay, is equals to 20 while t is equals to 0. Okay, and then for this one, we find the slope. Okay, what we get is 55 over 30 t plus 20 at the condition 0 to 30 like this. Okay, then we can have a constant value which is 75, okay, when t is more than 30 minutes. Okay, so if I want to write this in terms of t in time domain for this tt, what I can write is t is equal to, we look at the first one first, which is 20. Okay, and this one is considered as a unit step. Okay, how I can write this is 20 st. Okay, so this one is the first one. For this line, this lengthening line, which you have slope here, okay, so it's like go up, the signal is turned upwards, means from this point, and then you'll go up like this, so it's positive. Okay, what is the slope? This one is 55 over 30, which is here is a ramp functions. Okay, so it's starting 55 and then it's from 0 t, right, and then st. Okay, then for this third line, this one, the final line, this one that's showing that 75. Okay, so this signal is supposed to be go upwards. Okay, if there's no changing, but now the signal is turned down, right, to this line, to this straight line which is constant. So when it's turned down, we put it as a negative. Okay, and then it's a ramp functions which is 55. We need to start with the slope, and then t is starting at 30. Okay, as a ramp function so at 30. So this one is in terms of time domain, but now the questions asks us to determine in S domain. Okay, let's rewrite again what we get from the previous time domain. Okay, we get a 20 st plus 55 over 30. Okay, and then tst okay, tst minus the slope, okay, then t minus 30 as t minus 30. Okay, this is a ramp, and this one is a step input. Okay, so now we apply the Laplace transform in terms of ts. Okay, what we get here is 20 s, okay, plus 5530, okay, and then 1 over s power of 2 minus 5530. Okay, so what we get here is 1 s 2. Okay, we got exponentials 9030 s. Okay, so this one we get it from what we have done as previous one. Okay, if you check the previous one, so we have this Laplace transform from this time domain to get it as a S domain. Okay, so maybe we can rewrite it in the simplest form that we can write ts 20s plus 5530. Okay, 1 over s 2. I can write this to simplified form in this way. Okay, so this one is a t in S domain. Okay, so let's say I want to check my answer. Okay, I don't know whether this answer is correct or not. Maybe I can use MATLAB. Okay, let's this example I use MATLAB. Okay, to check whether my time domain here is correct or not. Okay, so I can use SYMS TS in this MATLAB. Okay, I define T and S. Then this one is my T domain. Okay, 20. Okay, I write exactly what I get it at the T domain in the previous slide. So when I can inverse Laplace this one, and then I also can plot again this in the time domain. Okay, so what I get is exactly the same plot as the previous one. Okay, okay, so okay then, thank you.